Bath lights can be on the same circuit as bathroom receptacle outlets. According to the National Electrical Code, ground fault circuit interrupter protection is required for outlets in bathrooms within 6 feet of water sources, including showers, bathtubs, and sinks. However, ground fault circuit interrupter protection is not explicitly required for light fixtures in bathrooms. It is strongly recommended to provide ground fault circuit interrupter protection for all bathroom lights. In the event of a ground fault, electrical current flowing to the ground unintendedly, a ground fault circuit interrupter will trip and interrupt the electrical circuit, reducing the risk of electrical shock. Some local electrical codes may require ground fault circuit interrupter protection for bathroom lights. It is easier to install ground fault circuit interrupter protection for the lights at the same time as the receptacles. If the bath lights are on the same circuit as the bathroom receptacles, the total load in the circuit must not exceed 20 amps. This includes the amperage drawn by the lights and the receptacles. To ensure this, you may need to use energy-efficient light bulbs or consider a separate circuit for the lights. When determining the proper wiring and electrical configuration for bathroom circuits, it's important to understand several key aspects of the National Electrical Code and electrical safety practices. Firstly, let's discuss the 20 amp circuit requirement for bathroom receptacles. The National Electrical Code mandates that at least 120 ampere branch circuits serve the receptacle outlets in a bathroom. This requirement is in place to accommodate the higher power demands of appliances commonly used in bathrooms, such as hair dryers, curling irons, and electric shavers. Using a 20 amp circuit prevents overloading the circuit and reduces the risk of tripping the breaker when multiple appliances are in use simultaneously. Secondly, we need to consider the placement of receptacles in bathrooms and the ground fault circuit interrupter protection requirements. The National Electrical Code specifies that receptacles installed in bathrooms must be ground fault circuit interrupter protected. This requirement is intended to protect individuals from electric shock in the damp environment of a bathroom, where the risk of electrical hazards is higher. Ground fault circuit interrupter protection works by monitoring the current flowing in a circuit and quickly interrupting the power supply if it detects a ground fault, which is an unintended path of current to ground. Receptacles must be located within a certain distance of water sources such as sinks, bathtubs, and showers to be compliant with the National Electrical Code. As previously mentioned, the National Electrical Code does not explicitly require ground fault circuit interrupter protection for lighting fixtures in bathrooms. There are several reasons why it is highly recommended. Firstly, installing ground fault circuit interrupter protection for bathroom lights provides an additional layer of safety for occupants. In the event of a ground fault in a light fixture, the ground fault circuit interrupter will trip and de-energize the circuit, reducing the risk of electric shock. Secondly, some local electrical codes may require ground fault circuit interrupter protection for bathroom lights, even if it is not mandated by the National Electrical Code. It's important to check with local authorities to ensure compliance with all applicable regulations. Thirdly, installing ground fault circuit interrupter protection for bathroom lights can simplify the wiring process and reduce the risk of future electrical problems. By protecting all electrical devices in the bathroom with ground fault circuit interrupter protection, you can create a safer and more reliable electrical system. Next, let's address the issue of whether bathroom lights can be on the same circuit as bathroom receptacles. The National Electrical Code permits bathroom lights to be on the same 20 amp circuit as bathroom receptacles as long as the total load on the circuit does not exceed 80% of the circuit's rating, which is 16 amps. To ensure compliance with this requirement, it's important to calculate the total amperage drawn by all of the devices on the circuit, including the lights and the receptacles. If the total amperage exceeds 16 amps, you will need to either reduce the load on the circuit or install a separate circuit for the lights. To calculate the amperage drawn by the lights, you will need to know the wattage of each light bulb and the voltage of the circuit. The formula for calculating amperage is amps equals watts divided by volts. For example, if you have 460 watt light bulbs on a 120 volt circuit, the total amperage drawn by the lights would be 2 amps or 240 watts divided by 120 volts. To calculate the amperage drawn by the receptacles, you will need to estimate the maximum load that will be plugged into each receptacle at any given time. A common rule of thumb is to assume that each receptacle will draw at least 1.5 amps. However, if you know that certain appliances, such as hairdryers or curling irons, will be used in the circuit, you will need to account for their higher amperage draw. If the total amperage drawn by the lights and the receptacles exceeds 16 amps, you have several options. Firstly, you can reduce the load on the circuit by using energy-efficient light bulbs such as LED bulbs, which draw significantly less power than traditional incandescent bulbs. Secondly, you can install a separate circuit for the lights, which will reduce the load on the receptacle circuit and ensure that it does not exceed its rated capacity. Thirdly, you can install a larger circuit breaker, such as a 25 amp or 30 amp breaker, to accommodate the higher load. However, this option is not recommended, as it can increase the risk of overloading the circuit and causing a fire. In addition to the above considerations, it's also important to ensure that all wiring and electrical work in the bathroom is performed by a qualified electrician and complies with all applicable codes and regulations. Improper wiring can create a serious safety hazard and increase the risk of electric shock or fire. It's also important to regularly inspect your bathroom's electrical system for any signs of damage or wear, such as frayed wires, cracked outlets, or loose connections. If you notice any problems, contact a qualified electrician to have them repaired as soon as possible. Understanding the specific requirements outlined in the National Electrical Code is essential for ensuring electrical safety and code compliance in bathroom installations. The National Electrical Code, a comprehensive set of standards published by the National Fire Protection Association, provides detailed guidelines for electrical installations in buildings, including bathrooms. Firstly, the National Electrical Code mandates the use of ground fault circuit interrupter protection for all 125 volt, 15 ampere and 20 ampere receptacles installed in bathrooms. This requirement is in place to protect individuals from electric shock hazards in the damp environment of a bathroom. Secondly, the National Electrical Code specifies the placement requirements for receptacles in bathrooms. Receptacles must be installed within 3 feet of each basin, and at least one receptacle must be installed within 3 feet of each bathtub or shower. These requirements ensure that receptacles are readily accessible for plugging in appliances such as hair dryers and electric shavers. Thirdly, the National Electrical Code addresses the use of lighting fixtures in bathrooms. While ground fault circuit interrupter protection is not explicitly required for lighting fixtures, it is strongly recommended, especially for fixtures located near water sources. The National Electrical Code also specifies the minimum clearance requirements for lighting fixtures installed above bathtubs and showers. Fourthly, the National Electrical Code provides guidelines for the wiring of bathroom circuits. A dedicated 20 ampere branch circuit is required to serve the receptacle outlets in a bathroom. This circuit can also supply power to lighting fixtures and other electrical devices in the bathroom, as long as the total load on the circuit does not exceed 80% of the circuit's rating. Fifthly, the National Electrical Code addresses the use of exhaust fans in bathrooms. Exhaust fans are required in bathrooms to remove moisture and prevent the growth of mold and mildew. The National Electrical Code specifies the ventilation requirements for exhaust fans, including the minimum airflow rate and the proper installation of ductwork. In addition to the specific requirements for bathrooms, the National Electrical Code also includes general requirements for electrical installations that apply to all areas of a building. These requirements cover topics such as wiring methods, grounding, overcurrent protection, and equipment installation. Electrical safety is paramount in bathroom environments due to the presence of water and the potential for electric shock. Ground fault circuit interrupters are essential safety devices that protect individuals from electric shock by monitoring the flow of current in a circuit and quickly interrupting the power supply if a ground fault is detected. Ground fault circuit interrupters should be tested regularly to ensure that they are functioning properly. Proper grounding of electrical equipment is also critical for electrical safety. Grounding provides a low resistance path for fault current to flow back to the source, which helps to trip the circuit breaker and prevent electric shock. All electrical equipment in a bathroom, including receptacles, lighting fixtures, and exhaust fans, should be properly grounded. Wiring should be installed according to the National Electrical Code and local electrical codes. Wires should be properly sized for the load that they will be carrying, and connections should be made securely to prevent loose wires or short circuits. Overcurrent protection devices, such as circuit breakers and fuses, should be installed to protect electrical circuits from overloads and short circuits. These devices will trip and interrupt the power supply if the current exceeds the rated capacity of the circuit. Regular inspection and maintenance of electrical systems are essential for identifying and correcting potential hazards. Receptacles, switches, lighting fixtures, and other electrical equipment should be inspected regularly for signs of damage or wear. Any damaged or worn equipment should be replaced immediately. Ground fault circuit interrupters should be tested monthly to ensure that they are functioning properly. By following these electrical safety practices, you can help to prevent electric shock and ensure a safe bathroom environment. Selecting the appropriate wiring methods and materials for bathroom circuits is crucial for ensuring safety, reliability, and compliance with electrical codes. Non-metallic sheath cable, commonly known as Romex, is a popular wiring method for residential applications, including bathrooms. Non-metallic sheath cable consists of 2 or more insulated conductors enclosed within a non-metallic sheath. It is relatively inexpensive and easy to install, making it a popular choice for many homeowners. However, non-metallic sheath cable is not suitable for use in wet or damp locations, such as bathrooms, unless it is specifically marked as being moisture resistant. Armored cable, also known as BX cable, consists of insulated conductors enclosed within a flexible metal sheath. Armored cable provides better protection against physical damage than non-metallic sheath cable, making it a suitable choice for areas where the wiring may be exposed to impact or abrasion. Armored cable is also more resistant to moisture than non-metallic sheath cable, making it a better choice for bathrooms and other damp locations. Conduit is a rigid metal or plastic tubing that is used to protect electrical wiring. Conduit provides the best protection against physical damage and moisture, making it the preferred wiring method for commercial and industrial applications. Conduit is also required in some residential applications, such as underground wiring and wiring in hazardous locations. When selecting wiring materials for bathroom circuits, it is important to choose materials that are rated for the environment in which they will be installed. Wires and cable should be rated for the voltage and amperage that they will be carrying, and they should be suitable for use in wet or damp locations if necessary. Electrical boxes should be made of non-corrosive materials, such as plastic or galvanized steel, to prevent rust and corrosion. Connectors and fittings should be properly sized and installed to ensure a secure and reliable electrical connection. By selecting the appropriate wiring methods and materials for bathroom circuits, you can ensure that your electrical system is safe, reliable, and compliant with electrical codes. Ensuring code compliance for bathroom electrical installations is essential for safety and legal reasons. Building permits are typically required for electrical work in bathrooms, including new installations, renovations, and repairs. Building permits ensure that the work is inspected and approved by a qualified electrical inspector. Electrical inspections are conducted by local building departments to verify that electrical work complies with the National Electrical Code and local electrical codes. Electrical inspectors will examine the wiring, grounding, overcurrent protection, and other aspects of the electrical system to ensure that it is safe and code compliant. Compliance with the National Electrical Code is mandatory for all electrical installations in the United States. The National Electrical Code provides detailed guidelines for electrical installations, including wiring methods, grounding, overcurrent protection, and equipment installation. Local electrical codes may have additional requirements that are not covered by the National Electrical Code. It is important to check with your local building department to determine the specific electrical codes that apply to your area. Failure to comply with electrical codes can result in fines, penalties, and even legal action. It can also create a dangerous situation that could lead to electric shock, fire, or other hazards. By ensuring code compliance for bathroom electrical installations, you can protect yourself, your family, and your property from electrical hazards. Integrating energy-efficient lighting solutions into bathroom designs can significantly reduce energy consumption and lower utility bills. LED lighting is a highly energy-efficient option for bathrooms. LED bulbs use up to 75% less energy than incandescent bulbs and last much longer. LED bulbs are also available in a wide range of colors and styles, making them a versatile choice for any bathroom design. Compact fluorescent lighting is another energy-efficient option for bathrooms. Compact fluorescent bulbs use about 75% less energy than incandescent bulbs and last up to 10 times longer. Compact fluorescent bulbs are available in a variety of shapes and sizes, making them a suitable choice for many different lighting fixtures. Motion sensors can be used to automatically turn lights on and off when someone enters or leaves the bathroom. Motion sensors can help to reduce energy consumption by ensuring that lights are only on when they are needed. Dimmers can be used to adjust the brightness of lights in the bathroom. Dimmers can help to create a more relaxing and comfortable atmosphere, while also saving energy. By integrating energy-efficient lighting solutions into bathroom designs, you can reduce your energy consumption, lower your utility bills, and create a more sustainable home. Understanding the impact of moisture on electrical components is crucial for ensuring safety and preventing electrical hazards in bathrooms. Moisture can cause corrosion of electrical components such as wiring, receptacles, and switches. Corrosion can lead to electrical shorts, which can cause fires or electric shock. Moisture can also reduce the insulation resistance of electrical wiring, which can increase the risk of electric shock. Ground fault circuit interrupter protection is essential for protecting individuals from electric shock in wet or damp locations such as bathrooms. Ground fault circuit interrupters work by monitoring the flow of current in a circuit and quickly interrupting the power supply if a ground fault is detected. Electrical components should be installed in locations where they will not be exposed to direct water spray or splashing. For example, receptacles should be installed at least 3 feet away from sinks, bathtubs, and showers. Electrical boxes should be sealed to prevent moisture from entering. Electrical boxes should be made of non-corrosive materials such as plastic or galvanized steel. Wiring should be protected from moisture by using moisture-resistant wiring methods such as armored cable or conduit. By understanding the impact of moisture on electrical components and taking appropriate precautions, you can help to prevent electrical hazards in bathrooms. Choosing between shared versus dedicated circuits for bathroom lighting involves considering several factors related to electrical load, safety, and code compliance. Firstly, electrical load considerations are paramount. A shared circuit means that the bathroom lighting is powered by the same circuit as other electrical devices in the bathroom, such as receptacles. This can be acceptable if the total electrical load on the circuit does not exceed the circuit's capacity. However, if the combined load of the lighting and other devices is too high, it can overload the circuit and cause the circuit breaker to trip. A dedicated circuit, on the other hand, is used exclusively for the bathroom lighting. This ensures that the lighting has its own dedicated power supply and is not affected by the electrical load of other devices. Secondly, safety considerations come into play. Sharing a circuit between the bathroom lighting and receptacles can increase the risk of electrical hazards, especially if the circuit is overloaded. Overloaded circuits can overheat and potentially cause fires. A dedicated circuit for the bathroom lighting reduces this risk by ensuring that the lighting is powered by its own separate circuit. Thirdly, code compliance is a key factor. Electrical codes, such as the National Electrical Code, may have specific requirements regarding shared versus dedicated circuits for bathroom lighting. These requirements are designed to ensure electrical safety and prevent electrical hazards. In some cases, electrical codes may require a dedicated circuit for the bathroom lighting, especially if the lighting is located near water sources. Cost is another consideration. Installing a dedicated circuit for the bathroom lighting can be more expensive than sharing a circuit with other devices. This is because it requires running a separate circuit from the electrical panel to the bathroom, which can involve additional labor and materials. The decision between a shared versus dedicated circuit for bathroom lighting depends on several factors, including electrical load, safety, code compliance, and cost. It is important to carefully consider these factors and consult with a qualified electrician to determine the best solution for your specific situation. Implementing best practices for ground fault circuit interrupter protection in bathrooms is essential for ensuring electrical safety and preventing electric shock. Ground fault circuit interrupters should be installed in all bathrooms to protect individuals from electric shock in wet or damp locations. Ground fault circuit interrupters should be tested regularly to ensure that they are functioning properly. Ground fault circuit interrupters should be replaced if they fail to trip when tested. Ground fault circuit interrupters should be installed in easily accessible locations so that they can be tested and reset easily. Ground fault circuit interrupters should be installed according to the manufacturer's instructions. Ground fault circuit interrupters should be wired correctly to ensure that they function properly. Ground fault circuit interrupters should be used in conjunction with other electrical safety practices, such as proper grounding and wiring. Ground fault circuit interrupters should not be relied upon as the sole means of electrical protection. Regular inspection and maintenance of electrical systems are essential for identifying and correcting potential hazards. By implementing these best practices for ground fault circuit interrupter protection, you can help to prevent electric shock and ensure a safe bathroom environment. Addressing common misconceptions about bathroom electrical safety is crucial for promoting safe practices and preventing electrical hazards. One common misconception is that ground fault circuit interrupters are not necessary in bathrooms if the electrical system is properly grounded. While grounding is an important safety measure, it does not provide the same level of protection as ground fault circuit interrupters. Ground fault circuit interrupters can detect ground faults that grounding may not detect, and they can trip much faster than circuit breakers. Another common misconception is that ground fault circuit interrupters only need to be installed near water sources, such as sinks and bathtubs. While it is true that ground fault circuit interrupters are required near water sources, it is also a good idea to install them throughout the bathroom to provide comprehensive protection. Another misconception is that ground fault circuit interrupters are foolproof and never fail. While ground fault circuit interrupters are very reliable, they can fail over time. It is important to test ground fault circuit interrupters regularly to ensure that they are functioning properly. Another misconception is that it is safe to use extension cords in bathrooms if they are not near water sources. Extension cords should not be used in bathrooms because they can create a tripping hazard and increase the risk of electric shock. Another misconception is that it is safe to perform electrical work in bathrooms if you are careful. Electrical work in bathrooms should only be performed by qualified electricians. There are too many potential hazards involved to attempt to do it yourself. By addressing these common misconceptions about bathroom electrical safety, you can help to promote safe practices and prevent electrical hazards. Reviewing relevant National Electrical Code articles for bathroom electrical installations is essential for ensuring code compliance and safety. Firstly, National Electrical Code Article 210.8 covers ground fault circuit interrupter protection for personnel. This article specifies the requirements for ground fault circuit interrupter protection in bathrooms, including the types of receptacles that must be protected and the locations where ground fault circuit interrupters must be installed. Secondly, National Electrical Code Article 210.11 covers branch circuits required. This article specifies the requirements for the number and type of branch circuits that are required in bathrooms, including the 20 ampere small appliance branch circuit that is required to serve the receptacles in the bathroom. Thirdly, National Electrical Code Article 404.4 covers location of switches. This article specifies the requirements for the location of switches in bathrooms, including the requirement that switches be located at least 3 feet away from sinks, bathtubs, and showers. Fourthly, National Electrical Code Article 410 covers luminaires, lamp holders, and lamps. This article provides requirements for the installation of lighting fixtures in bathrooms, including the minimum clearances that are required above bathtubs and showers. Fifthly, National Electrical Code Article 430 covers motors, motor circuits, and controllers. This article provides requirements for the installation of exhaust fans in bathrooms, including the ventilation requirements and the wiring requirements. By reviewing these relevant National Electrical Code articles, you can ensure that your bathroom electrical installations are safe, code compliant, and well designed.